This is part 2 in our video series about making gram to mole and mole to gram conversions and estimating before we do our math. Please make sure you watch the first part of this video first. These learning goals should look familiar to you. Again, we are continuing another practice problem, making an estimation and then converting between a substance in moles and in mass. A procedure calls for 0.45 moles of hydrogen peroxide, H2O2. You have 78 grams of hydrogen peroxide in a beaker. First question here says 0.45 moles of hydrogen peroxide is how many grams? And the second question says 78 grams of hydrogen peroxide is how many moles? So I am converting from moles to grams and from grams to moles. I'm going to go through 4 steps in this problem instead of 3 because this time I have to start by finding the molar mass of H2O2 using the periodic table. Then I'm going to use the molar mass to estimate my answer. Then I'm going to actually calculate using my dimensional analysis or the molar mass as a conversion factor. And finally, I'm going to think about my answers compared to my estimations. So pause the video, take a moment to start going through steps 1 through 4. Preferably try to get all the way through to step 4 before playing the video again so that you can really get all the practice that you can. But if you get stuck anywhere, you can come on back and we will go through this together. Hopefully you paused the video and tried a little bit of this on your own. We're going to start with step 1, calculating the molar mass of H2O2 using the periodic table. So the molar mass of H2O2 should be 2 times the molar mass of H plus 2 times the molar mass of O. Looking at my periodic table of elements, I can quickly find O and H, and I can look at the top left corner to see the molar masses of each of those elements. So the molar mass of H was 1.00794 grams per mole. The molar mass of O was 15.9994 grams per mole. You may have a teacher who tells you to round your molar masses of the elements off to a certain number of significant figures or place value. I'm just going to keep all of the significant figures, but you can listen to your teacher on that. So the molar mass of H2O2, keeping all of the significant figures, is 2 times 1.00794 grams per mole plus 2.15.994 grams per mole. I end up with a molar mass of 34.01468 grams per mole. So that's the molar mass of H2O2. 602 hexillion hydrogen peroxide molecules have a mass of 34.01468 grams. So now that I have my molar mass, I'm going to use that molar mass to estimate my answers. So if I have 0.45 moles, about how many grams do I estimate that would be? Watch what I'm going to do here to estimate. I'm going to say, okay, 0.45 is kind of close to 0.5, right? Half. And that's a much easier number to make estimations with. 1/2 is a great mental math number. So I'm going to say, all right, I've got about 1/2 of a mole, or about 0.5 moles. And I don't really want to deal with the molar mass when I'm making an estimation in this really expanded decimal form. I'm going to round 34.01486. I'm going to round that to 34 because that's very close to 34. So 1/2 of 34 should tell me about how many grams are in 0.545 moles of hydrogen peroxide. So 34 divided by 2 is 17. So 0.45 moles of H2O2 should be somewhere near 17 grams because that seems like somewhere near half of the molar mass of hydrogen peroxide. 78 grams of hydrogen peroxide, let's see if we can estimate how many moles that should be. So 78 grams, if I know that there's like about 34, 35 grams in 1 mole, I'm actually going to round in my head to 35 just to, again, make the numbers here a little bit easier. Then I can use some reasoning to figure out how many times 35 can be found in the number 78, right? So let's think about this. 35 plus 35 is 70. So there's 70 grams in 2 moles. That's pretty close to 78. So 78 grams should be a little more than 2 moles. Definitely less than 3 moles, right? 105 grams would be in 3 moles here. So it's going to be less than 3, but more than 2. So I will say approximately 2 moles, probably a little bit more. It should be in 78 grams of hydrogen peroxide. Once we have our estimations, we're now going to move on to make our calculations. So just like last time, the first thing we're going to do is take the given information and put it on our starting line. So remember, our given information is not the molar mass. The given information is either the moles or the grams. So 0.45 moles is our given information for problem number 1. Our molar mass is going to go as a conversion factor next, and I'm going to put the unit that I am starting with, so in this case moles, in the denominator of my molar mass conversion factor. So 1 mole will go in the denominator, and the grams, 34.01468, will go in the numerator. Moles will cancel out, and I will be left with the unit grams. So in the calculator, I will type in 0.45 times parentheses 3.01468 divided by 1. And I'm going to round my answer to 2 significant figures. So I should end up with 15 grams. For my second problem, I'm starting with 78 grams, and I want to, this time, put grams in the denominator of my molar mass conversion factor and moles in the numerator. Grams will cancel out or reduce to 1, and I will type in the calculator 78 times parentheses 1 divided by 34.01468. And again, I'm going to round to 2 significant figures to get my answer, and I will get 2.3 moles. So I've got 15 grams and 2.3 moles as my answer. Let me go back and compare those answers to my estimates. So I thought that 0.45 moles of hydrogen peroxide would be about 17 grams, and I calculated 15 grams. That works. I estimated that 78 grams of hydrogen peroxide should be about 2 moles, and I calculated 2.3 moles. So my estimation still matches the calculations that I made. What's really useful about estimating before we calculate is that we can just make sure that if we set up our conversion factor incorrectly and we end up dividing where we should have multiplied, we have a way to check ourselves and better understand what those numbers are actually representing in the real world. So let's check back in on our learning goals. Hopefully you feel that you are able to use the molar mass and given information about a problem to estimate before solving a calculation, and that you're able to go through and calculate the mass of a substance in grams or the moles of a substance given one of the other. If you're still not feeling super confident with these types of conversions, there are a ton of really awesome resources, both online and throughout the CK12 website, that can help you practice grams to mole and mole to grams conversions. So please ask for help, and it's totally okay if this is still confusing. It does take some practice. Way to go.